Good morning, students. Today's topic is about Introduction to Engineering Graphics. I am G. Raja, Assistant Professor, Department of Mechanical Engineering from Vellore College of Engineering and Technology. In engineering graphics, the primary component of the drawing is you have to margin the drawing sheets. Here you can see this is the entire drawing sheet which you have a title block. This is also in this title block you can write the name and your details, which class you are studying, and this area is the place. This area is the place where you have to diagram. The drawing sheet is trimmed shape is A4 size. A4 size is this shape, and depending on the various standard sizes are A0, A1. From starting from A0 to A4, the sizes vary. Most of us we use the drawing sheet is A2 sheets is often used in the drawing sheets for our engineering drawing. Orientation. This is the orientation of the drawing sheet. This is the drawing space and title block for A0 to A4. For A4 only, this is the title block, and these are the corners are where you have to draw the border shapes. Sample drawing sheet. This is the sample drawing sheet. In the title block, you have to give the which view we are to giving, and this is the sample drawing sheet. This is the drawing layout. For example, in the title block, what is the title? What is the title of the drawing or drawing? For example, it is a connecting rod or wheel bearing or something. Which the diagram is to be drawn is to be the title is to be written here. Name, what is your name, and checked by the sign and date version. These are the types of pencils used in engineering drawing. The three types of pencils are mainly used: the hard leads, medium leads, and soft leads. Hard leads are used for the technical drawing. The entire part which is to be drawn in 4H to 9H pencils, and the medium lead is used for the construction. General use instrument drawings are soft sketching. Softs are used for artwork and for the soft drawings. These are the different types of lines which are used in engineering graphics. First one is the thick line, outlines, visible lines, surface boundaries of the objects, margin lines. Next is the continuous thin lines. These are used for mentioning the dimension or extension lines or section lines, construction lines or border lines. This is the continuous thin wavy lines. It is mainly drawn for break lines or irregular contours or which can be drawn as a freehand, and the continuous thin zigzag lines. It is mainly used for long break lines, and short dashes with the gap 3 mm. These are mainly used for invisible surfaces or interior surfaces. Next one is the short dashes. These short dashes with the dot among center is used for center lines, locus lines, alternate long lines. And the next is the cutting plane line. Cutting plane lines different from the short dashes. The next one is the cutting plane lines. Cutting plane line is different from the short dashes, which is drawn very thick. These are the continuous thin plane lines. Next, this is the arrowhead. Arrowhead should be uniform in size, and the shape the shape should be maintained throughout the drawing. And the length and width of the should be 3:1. The length is 3 times the width. For example, this is the length of the arrowhead. This is the length of the arrowhead. This is 3 times to the this width of the arrowhead. This should be this is the open arrow, this is the closed arrow, and this is closed and filled arrow. The three types of arrow, any arrow can be used, but the procedure is to be followed 3:1 with the length size. Next is dimensioning. There are three types of dimensioning. One is the chain dimensioning, and another one is the parallel dimensioning, and another one is the combined dimensioning. Chain dimensioning is also called as continuous dimensioning. All the dimensions are aligned in such a way that an arrowhead of one dimension touches to the tip arrowhead where an adjustment dimension. The overall dimension is placed outside the smaller dimensions. Parallel dimensioning, it is also called as progressive dimensioning. All the dimensions are shown from the common reference line. Obviously, all these dimensions share common extension line. The extension line is very common. This method is adopted when the dimension have to be established from a particular datum surface. Combined is chain and parallel dimensioning. When combined and used, it is called as the combined dimensioning. These are in this drawing you can clearly understand what is meant by chain dimensioning, parallel dimensioning, and combined dimensioning. In chain dimensioning, the reference point changes from the another point. For example, from here you are taking 160 mm and this length is 70 mm and this length is 200 mm. In parallel dimensioning, the reference line, this reference line is common. You are taking the line for see here, this reference line is common. This is common reference line from where this is 150 mm. From here it is 420 mm and from here it is 640 mm. In this both the in this combined in this when the both the methods in and parallel dimensioning are used on the same drawing, the method of dimensioning is called as the combined dimensioning. This is the dimension line. You have to specify the dimension line like that. Okay, to with arrowhead in center you have to write the 64.21 mm. Here it is 13 mm. This is called as the extension line. For example, if you are not able to place the dimension here, you can bring an arrow here and you can dimension like that. For example, here see that one component is dimension here. It is the plus or minus is called as the tolerance level. This is the diameter symbol. You have to clearly know about that. This is called as the leader line. For example, you are going to measure the give the dimension of this circle. You can give by leader line. See here, this dimension is for angle. Double-headed arrow is enter. You can place the angle. Which angle you have to see here. These are the geometric constructions. You are already know that this is the acute angle, this is obtuse angle, this is right angle. The types of triangles you are maybe aware in small level classes: equilateral triangle, isosceles triangle, scale and triangle. This is scale and triangle. Then next is the square, rectangle, rhombus, pentagon, hexagon, trapezoid. In main in this engineering graphics subject, square, rectangle, pentagon, hexagon and circle, in which all the shapes you can draw the for a projection of solids. This is called as the solids. These are called as, in previous slide we can see the planes. In this slide we are going to see about the solids. This is tetrahedron, this is hexagonal prism, this is octahedron, this is isohedron, square prism, cube, right circular cone, right circular cylinder. These are the basic shapes used in the engineering graphics. These are called as the curved surfaces. You are studied in small classes: sphere, ellipse, parabola and hyperbola. These are the different types of lines. This is called as parallel line, non-parallel line, perpendicular line, intersecting line, tangent line and a normal line. Tangent line is a line that passes through any of the point through the circle. Dividing a line. Conic curves. We can. This is the right circular cone. Okay. For example, if you cut a cone in center and see the surface, it will be circle in shape. If you cut a cone with some angle, it is called as the ellipse. The further the angle is increased, is parabola. If the cone is cut perpendicularly, it is called as hyperbola. These are the conic section. Conic is defined as the locus of the point moving in a plane such that the ratio of distance from the fixed point and a fixed straight line is always constant. Fixed point is called focus. This point is called focus. Ellipse has a two focus point and a fixed line. This line is called as the directrix line. This line is called as the directrix line. Okay. What is meant by eccentricity? Eccentricity is the distance of the point from the locus to the distance of the point from the directrix. Okay, distance of the point from the locus to the distance of the point from the directrix. When the eccentricity value is less than 1, it is called as ellipse. When the eccentricity value is less than 1, it is called as ellipse. When it is equal to 1, it is called as parabola. When it is greater than 1, it is called as hyperbola. Okay, these constructions can be seen in